Hello and welcome to today's video. Happy Pi Day! Today we are looking at some GCSE worded questions on arcs and sectors. We're looking at 5 different GCSE questions which are worth a total of 25 marks, and these have been taken from past AQA and Edexcel papers. To skip through to a particular question, have a look at the timestamps below and skip to the relevant question for yourself. I'd advise that you attempt the question first and then mark it and then have a look at the questions in the video. I would recommend that you attempt the questions first and then watch the video. And if there's anything else that I can help you with at the end, please let me know. So let's get started. Let's have a look at this question. It's from the Edexcel June 2017 paper. It's paper number 2 higher, and it's question number 17, which is worth 5 marks. ONQ is a sector of a circle with the centre O and a radius of 11. So let's mark some length. So this distance here is the radius, so this is 11 centimetres. A is a point on ON and B is a point on OQ such that AOB is an equilateral triangle of side 7. Okay, so this is 7, which means that this must be 4. And this is 7. And this is the radius, so this bit the whole thing must be 11, so this bit must be 4. And OQ is 11. We're also told it's an equilateral triangle. So in an equilateral triangle, all of the angles are 60 degrees. So I want to calculate the area of the shaded region. So this shaded region is basically the sector minus the triangle. So the area of shaded region is equal to the area of sector minus the area of the triangle. So let's work out the area of the sector and the area of the triangle. So area of sector. So the formula for this is theta divided by 360 times pi r squared. So theta in this case is 60 divided by 360 times pi. Now the radius of this large sector is 11, so pi times 11 squared. So if we work this out, 60 divided by 360 is 1/6. 11 squared is 121. Okay, and if we want that as a decimal, we can just type the whole thing in. If you want it as a decimal, you can type it in from the beginning. So 60 over 360 times pi times 11 squared. So we need it to 1 decimal place, so let's just go to 2 decimal places for now. 63.36 centimeters squared. Now let's work out the area of the triangle. So the best formula to use here would be a half AB sine C. So half. Now A and B would be these two lengths here, 7 and 7. Sine, and then C would be 60 degrees. Yeah. So sine 60 is root 3 over 2 times a half is root 3 over 4 times 7 times 7, which is 49 root 3 over 4. 0.5 times 7 times 7 times sin 60, which is 49 root 3 over 4, which has a decimal, is 21.22. So the shaded region, calculate the area of the shaded region as a percentage of the area of that. So let's find out the shaded region. So that's going to be the area of the sector, which is 63.36 minus 21.22. 63.36 minus, and then I'm just going to use the answer, which is 42.14. Calculate the area of the shaded region as a percentage of the area of the sector. So the percentage of the shaded region is equal to the area of the shaded region, which is 42.14, divided by the area of the whole sector, which was 63.36, multiplied by 100. So 42.14 we already have there. We use answer over 63.36 times 100. And this gives us 66.5% to one decimal place. So let's have a look at AQA November 2017 higher paper number 2 question 22, which is worth 5 marks. So the cross section of an earring is a semicircle, center C, radius 25. So that's the diagram on the left here. The earring is black and white, so the shaded area is the black part and then the white area is the white part. Sector BCD is white and has a radius of 12, so that's this diagram here, is more than 20% of the semicircle white. So it's more than 20% of this white. So this requires us to work out the area of the semicircle and the area of the sector. So let's work out the area of this large semicircle. The formula for the area of a semicircle is the area of a circle, pi r squared, divided by 2. So that's pi times the radius, which is 25 squared, divided by 2. Pi times 25 squared over 2, the decimal is 981.75. I'm going to go more accurately to start off with, and then I'll use less accuracy later on. So that's in millimeters squared. Now the area of the sector, formula for that is theta divided by 360 times pi r squared. So theta is the angle, which is 150, over 360 times pi times r, which is 12 in this sector, squared. Let's type this in. So that's 60 pi, which is 188.50. Is more than 20% of the semicircle white. So we need to work out what percentage of the semicircle is white. So the percentage that is white is worked out by the amount that is white So the white area divided by the total area times 100. So the white area we worked out as 188.5. The total area was 981.75 multiplied that by 100. So 188.5 divided by 981.75 times 100. This is 19.20%. So 19.20% of the earring is white. So the answer to my question is more than 20% of the semicircle white? No. And my working out backs that up. Let's have a look at this question. It's from AQA June 2017. It's high paper number 2, question 25, which is worth 5 marks. The diagram shows a logo. ABE and DCE are congruent triangles and BCE is a sector of a circle with a center E. Show that the area of the logo is 510 centimeters squared. So this is the logo, which is made up of 2 triangles. So triangle ABE, triangle CDE, and sector BCE. And what we need to do is we need to work out the area of these 3 and add them up. And hopefully that gives us an area of approximately 510 centimeters squared to 2 significant figures. So let's start off by looking at triangle ABE. So I want to work out the area of the triangle. So triangle ABE is equal to a half AB sine C. That's half times A and B will be 15 and 26 and sine 38. So that's 0.5 times 15 times 26 times sin 38. That's 120.05. Now, triangle CDE is congruent, so it's going to have the exact same area. So I'm just going to copy the answer down. So now we need to find the area of the sector. Now the formula for the area of a sector is theta divided by 360 times pi r squared. Now theta is 108, 360 is a constant, pi is a constant, r is over here, or here. Now r is a value that we don't know, so we need to work out the value of r. So we're going to use triangle ABE to work out the value of r. We're going to do so by using the cosine rule. So the cosine rule for length is a squared equals b squared plus c squared minus 2bc cos a. So this is capital A. Okay, so the angle is always going to be of capital A. So this is little a. So little a is called r. So r squared is equal to b squared, which is the 15, that's opposite there, plus c squared. So this will be my c. So little c is 26. So 15 squared plus 26 squared minus 2 times 15 times 26 times cos of angle A, which is 38. R squared, I'm going to type that into my calculator. (15 squared plus 26 squared 26 squared minus 2 times 15 times 26 times cos 38. And I get 286.35. That's the value of r. So that's the value of r squared. So r will be the square root of that, which is equal to 16.92. So we can now substitute into this formula here. So theta is 108 divided by 360 times pi times 16.92 squared. So now 16.92 I already have here, so I'm going to square this, which is that, and I'm going to multiply that by pi, and then by the fraction 108 over 360, which gives me 269.88. So all we now need to do is add up these three values. $269.88 plus 120.05 plus 120.05. So we've got 269.88. We're going to add 120.05 and another 120.05. And that gives me 509.98. And the units for this are centimeters squared. Now, show that the area is this to two significant figures. If we round this to two significant figures, we get 510 centimeters squared. Let's have a look at this question. It's the Edexcel June 2017 higher paper number 3, question 18, which is worth 5 marks. A, B and C are points on a circle with a radius of 5 centimeters and a center of O. The A and DC are tangents to the circle. Okay, so first of all, if AD is a tangent to the circle, then this is 90 degrees. This is 90 degrees. Length DO is 9, so let's mark that in there. Work out the length of arc ABC. So arc ABC is this major arc here. We're trying to find out the length of this arc. Okay, so formula to work out the arc length is theta divided by 360 times 2 pi r. Now, for this arc here, we know that the radius is 5, but the angle theta is this one here. So we need to work out this angle, the major angle. So it's going to be bigger than 180 degrees. So in order to work that out, we'll need to work out the angle on this side. Okay, so if we can work out this angle, then we can do 360 minus that answer to get that one. Now, how can we work out this angle? Well, if we look here, we have a right-angled triangle, triangle OAD. If I redraw that, we have a right angle at A. So that's 90 degrees. We know that this is 5, and we know that this is 9. So we need to work out this angle. Let's call it X. So using basic trigonometry, we label the sides. So this is going to be the hypotenuse. So this is the right angle. So this is the hypotenuse. Angle is here. So this one is the opposite, and this one is the adjacent. So we need a formula using the adjacent and the hypotenuse. That would be cos. So cos x equals adjacent over hypotenuse. So cos x is equal to 5 divided by 9. So x is equal to the inverse cos 5 over 9. So inverse cos of 5 over 9. So angle x is 56.25. So this is 56.25, and this triangle here is going to be congruent. So this is going to be 56.25 because all the lengths are the same. So this whole angle here is going to be two lots of that. So to find theta, it's going to be 360 degrees because that's the full circle, minus 56.25 minus the other 56.25. So let's multiply this by 2 and then do 360 minus the answer. This gives us 247.5 degrees. So now that we know that theta is 247.5 degrees, we can substitute it into the arc length formula from above. So our arc length is equal to theta, which is 247.5 divided by 360 times by 2 times by pi times by r, which is 5. And we can type that all into our calculator at one go. Two 247.5 over 360 times 2 times pi times 5. And this gives me as a decimal 21.60. And so to three significant figures, that's 21.6 centimeters squared. Let's have a look at this question from Edexcel November 2017. It's higher paper number 2. It's question number 20, which is worth 5 marks. OAC is a sector of a circle with a center O and a radius of 10. 10 there as well. BA is a tangent to the circle at point A, and BC is a tangent. Okay, so these two are tangents. So tangent meets a circle, tangent meets a radius at 90 degrees. So we know these two angles are 90 degrees, and also these two tangents must be the same length. So we have a quadrilateral. It's actually a kite, but what I'm going to do is I'm going to split that in half down the middle. So we have two congruent triangles. We know that angle AOC is 120. Calculate the area of the shaded region. Okay, so the area of the shaded region is equal to the area of the quadrilateral minus the area of the sector. So area of the quadrilateral minus the area of sector. So this quadrilateral is made up of two congruent triangles. So what we're going to do is we're going to find the area of the triangle. Okay, so let's look at triangle AOB. So we know this is 90 degrees. We know that this is 10. And we need to find out the area of this. So we know that this is 60. So we can either work out the length of this, or we can work out the length of that bit there. So let's do the length of the hypotenuse here. So let's call the hypotenuse x. And if we label this triangle, then this is my hypotenuse. Angle is here, so this is my opposite, and this one is my adjacent. Using basic trigonometry here, we have the adjacent and the hypotenuse, so we need to use cos. So cos theta is adjacent divided by the hypotenuse. So theta is 60, so cos 60 is equal to the adjacent, which is 10, divided by the hypotenuse, which is x. So x cos 60 is 10, so x is equal to 10 divided by cos 60. So that's 10 divided by cos 60, which is 20, because cos 60 is a half. So we now know that x is 20, so that length there is 20. Now we can find the area of the triangle. So area of triangle AOB, using the formula a half AB sin C. So that would be a half times 10 times 20, because we just worked out x. 10 times 20 times sin 60. So 0.5 times 10 times 20 times sin 60. So this is 50 root 3, which means that the area of the other triangle, the area of triangle OBC, will be identical because it's a congruent triangle. So the area of our quadrilateral is 50 root 3 plus 50 root 3, so 100 square root 3. Now we work out the area of the sector, which is AOC. Area of sector AOC is theta over 360 times pi r squared. Now theta is 120 divided by 360 times pi times the radius, which is 10 squared. So 120 over 360 times pi times 10 squared. 100 over 3 pi, which is 104.72. So the shaded region is equal to the area of a quadrilateral, which is 100 root 3, minus the number that we've just worked out, 104.72. So if we subtract them, 100 root 3 minus the answer, we get 68.49, to three significant figures, 68.5 meters squared. Thank you for watching our video on arcs and sectors. I hope you found those questions interesting and managed to learn a few things. And I'd really appreciate it if you could give us a thumbs up, and if you haven't already done so, hit the subscribe button for more content like this. I will see you next time.